That wasn't a facetious. If you didn't hear me, when the picture of George made me look a lot younger, and then the picture of me was taken good 7, 8 years ago, so it even made me look a lot younger. So I would like to add my thanks to the sponsors because they let me be here in Barcelona. If it weren't for the sponsors, I wouldn't be here, and I like being in Barcelona. Okay, so the genesis of this talk is that I get questions like, I want to be a software architect, what do I need to know? And what I used to say, which is a very lazy response, is, well, you need some experience in order to be a software architect. You just can't go be a software architect. And that was an easy response, and I gave it for some number of years. And after a while, I got a number of these questions, and I actually thought about what it took to be a software architect. And I decided there are 5 categories of knowledge that you need. You need to know architecture principles. You need to know architectural styles or patterns. You need to know architectural processes, and you need to know the system environment, and you need to know tools and frameworks. So as categories, those are the things you need to know. So let's start with principles. The fundamental principle of software architecture is that you need to worry about business goals, and business goals will translate into quality requirements, and then quality requirements will translate into a design. Okay, so that's the fundamental principle. What do I mean by that? Well, how do you express the requirements? One of the things that I've seen a lot of is that requirements are so vague as to be meaningless. So requirements have to be concrete. That can be either user stories or quality attribute scenarios. And they have to be actionable. There we go. Now, how do you achieve quality attributes? There's a list. Okay, so if you're interested in availability, you have to pay attention to redundancy. Okay, this is independent of the kind of system you have. Redundancy is an important technique for achieving availability. You run down the qualities, and you can always add new ones. In English, I don't know about Spanish, but English is a very nice language. You get a new quality by adding ility at the end of the old one, and that's a new quality, and then you say, okay, how do I achieve that? And the answer is, I don't really know, but let me ask somebody that built a system that does that, and you end up with catalogs, and we called these things tactics when we did this. And in the best of all possible worlds, there's a model for the quality. Models exist for sum of performance. They don't exist for anything else. And so the best of all possible worlds is a long way away. And so an easy thing to do is just ask people that have done this. There we go. And I was asked, how have things changed? And this part of it, we wrote in the first edition of Software Architecture and Practice. We didn't have tactics then. So maybe the second edition of Software Architecture and Practice, and they haven't changed in, the 90s is now 20 years ago. So what goes next? Well, you don't design systems from first principles, or if you do, it'll take you a long time. And so what you do is you design systems from styles or patterns. You say, let me choose a style that satisfies the main quality attributes that I'm worried about, and that will codify what are my components, what are the coordination among the components, and what are my resource allocation schemes. So those are typically given in an architectural style. You can get into a big debate between architectural styles and architectural patterns, and I don't want to do that. Come on. And what happens is that you've chosen your particular style because it is good for the quality attributes that are most important to you. But the ones that are most important to you are not all of the quality attributes. And so now you have to start to compensate for the other quality attributes. And let me use microservice architecture as an example. So microservice architecture is really good for availability. It's really good for flexibility. It's good for choices of technologies. It's not so good for performance. Okay, and so what you have to do is you have to, if you're going to use a microservice architecture, you have to compensate for performance. Well, how do you do that? Well, one way is you use caching. Okay, let me cache IP addresses so I don't have to go look them up every time. Let me use a mid-tier discovery service so I don't have all those load balancers floating around, you know, things like that. So those are compensation mechanisms for performance. One of the problems of microservice architecture is that each team gets to choose their own technologies. It's one of the virtues, but it's also one of the problems. Now I have potentially inconsistent technologies. And so I have to have a common message passing protocol in order to compensate for the flexibility, the problems associated with flexibility. And I'll come back to this. Okay, so now I have a style and principles. Now I need processes. Okay, how in fact do I go from knowing what my requirements are to getting a design? How do I find out what my business goals are? Okay, you know, how do I do all this? And so you can define processes to do that. And let me start with business goals. People have categorized business goals, and presumably people in business schools, you know. And so this is a categorization from, I don't know what ME is, but somebody named Porter. And he has a list here. You have a number of different business goals that you might start out with. And here's the rest of this list. And you can use this to talk to your business people. One of the things I've discovered, having done this since I was a child, I don't know, seems like, is that you talk to people, you say, what business goals is this system supposed to answer? And they say, business goals? Yeah, I think there's some. So if you have a list, you know, it gets more meaningful for them. So one of the systems, actually I think we wrote about this in one of the books. It had a quality called Iowability, which we called Iowability. And the people we were talking to lived in Iowa. They had a workforce. The people that live in Iowa don't want to leave. If you know anything about U.S. geography, that's very strange, but you know, they're happy in Iowa. They wanted to keep the same workforce because they couldn't get other people to move to Iowa. And so we want people that we have to be able to use the new system that we're building. Okay? So that's a business goal. That was one of their goals of the system. And now you need to make that specific. What do you mean by that? What does it mean to make people comfortable with the new system? It means the user interface has to be simple. User interface has to be similar to the old one as much as possible. We need to keep it simple when we need to make it similar. So that's a concretization. I don't know if there's such a word. That's making concrete the business goals. So you move from the business goals to the quality, and then you make the quality concrete. Now you're mapping these architectural requirements and you want to move to the design. So you use styles and patterns to begin the process, use tactics to modify the styles and the patterns to either compensate or accentuate certain qualities, and you're making trade-offs. Okay, so now all of a sudden you're making trade-offs. You started making trade-offs as soon as you wrote down the business goals, because you have to prioritize the business goals. And then you continued making trade-offs when you made a style decision, because the style emphasis is good for some things and not good for others. And the trade-offs reflect the business goals, they reflect the constraints that you are under, they reflect the current state of the design. I've been working on this for a month. I have a design. We've coded some of it. Okay, we're coding as we go. We discovered we have a problem. So what are our options? Okay, you can start over again, or you can live with the problem, or something in the middle. Okay, and so that's the current state of the design and the current state of the implementation. Okay, how have these processes changed over time? It turns out that the DevOps movement, so my history is that I get bored easily. And so if you look at the various things that I've done, it kind of reflects that. I was in software architecture for a long time because that turns out to be a very rich domain. But then eventually I got bored with that and moved into DevOps. And so now all of a sudden I can talk about DevOps and architecture, and I can talk about how DevOps changes the kinds of requirements that you have. So one of the things that's happened these days is that operators are first-class stakeholders. That didn't used to happen. You just sort of ignored the operators. Continuous deployment. How do you design your system so that you can deploy, let's say we're in the microservice world, you can deploy a service without worrying about its dependencies or the things that are dependent on it. Okay, there are design things you can do. What happens when the developers are the first responder? And there are organizations where the developers carry pagers. That's something I learned. So somebody told me that, and I said, no one carries pagers anymore, right? Pagers are an obsolete technology. You use cell phones, right? You get a message. And the answer was no. Actually, it was Ian that told me this. The people carry pagers because pagers have guaranteed delivery, whereas cell phones do not. So that was something I learned. And these are all DevOps processes. So the processes are changing, not quickly, but when I first started, so I've been teaching a course in DevOps for about 5 years now. When I first started teaching it, it was, what is that all about? This semester I'm teaching this course. I get students that come and say, I've been a DevOps engineer for 2 or 3 years, and come talk to me. So it's gone from, I don't even know what you're talking about in industry, to it's now common practice. And so that's a fairly rapid change as these things go. The architect needs to know about both the business and the technical environment. So the execution environment. So what's the business environment? Well, you start to get involved in things like clients and suppliers. You start to get involved in competition, regulatory things. There are whole bunches of laws that affect things. GDPR is a new thing, and that affects what people do. Market and social and economic trends. Okay, all these are business considerations. The scope of the developer, a business consideration, what are we going to make our developers do? My developers don't like to carry pagers, so when I first got involved when I went to graduate school, I was a systems programmer. Okay, and at the time, systems programmers wrote I wrote an operating system, and I couldn't access the thing during the day because people were actually using the computer. So you signed up for time. I would go in the middle of the night. We would make some tests. I hated that. Okay, I do not want to carry a pager and be woken up at 3 o'clock in the morning. It is just not in my the things I can do. So, am I going to be a first responder? If yes, then I need to do things to make life easier. Am I in charge of quality attributes? I'm in quality assurance. Who does the testing? Sometimes developers do. Sometimes there's a QA system. You need to know these things. Who takes care of the deployment pipeline? Is this a developer responsibility? Is this a organization responsibility? Again, you need to know the scope of the activities. And the last couple years, time to market has become much more important than it used to. So the purpose of DevOps is to shorten the time to market from I'm done with the code until it's into production. That's started to become a dominant kind of theme. Time to market was always important, but it wasn't dominant. I think it's becoming much more dominant, and the consequence is that the developer responsibilities have changed. They've broadened. Now, what about the technical environment? Well, I can work in the cloud, I can work in an embedded system, I could work on a standalone system, I could work in a hybrid system. As an architect, I need to know the technical environment that the systems I'm writing live in. If I don't know that, then I'm going to be making mistakes. And let me just deal with the cloud because that's what I've been thinking about. Things that you kind of know, but you don't really know are, what about networks? What about messaging? What about security? What about containers? How does scaling work? Okay, so I mean, yes, you kind of knew all these things existed, but if in fact you're working in the cloud environment, and Ian will talk more about this, but if you're working in the cloud environment, you're in a large-scale distributed system, and there are lots of problems associated with distributed systems, and you need to know those problems, and you need to know whether they're going to affect you, and you need to know the solutions to it. How do I manage state? Significant expansion in the last decade, and that's because of the growth of the cloud. And even if you're in the embedded world, you're in the cloud world, one way or another. So lots of stuff you need to know. The place where there's just been an incredible explosion of things are in tools and frameworks. So I'm guessing, but they're probably somewhere, I never counted them, but they're probably somewhere in the order of 500 to 1,000 different tools in the DevOps space, if you tried to enumerate them. I mean, it's just, I don't know how anybody understands them all. And using a particular framework, you're now going to use a framework because why write it from scratch if it exists? All of a sudden, a lot of architectural decisions have been made, and you're using that framework, and that forces you into a particular style. And there have been an explosion of tools. So let me go back to microservice architecture, right? We talked about flexibility in terms of I talked about flexibility in terms of message passing. Protocol buffers are a way of dealing with that. So if you don't know what a protocol buffer is, you have a definition of the interface in a proto file. You have a compiler for your particular language. So I have a proto compiler for C. I have a proto compiler for Java. I write one service in C and the other service in Java. And the compilers produce libraries that get integrated into the system. That arrow should be double-headed because you call and have a response. So messages go both ways. And you can pass messages. So what's really interesting about protocol buffers to me is not the allowing you to exchange messages. It's the side effects. If I call a particular library on entry and exit, which is when I'm sending a message, I can record that. I can record what time was it called, what information was passed. All of a sudden I have a logging thing. So I can generate the logs automatically. I don't have to, as a developer, I don't have to worry about that. Okay, I need the logs for the first responders, and I can develop them automatically. So that's one side effect. The second side effect is I have some level of architecture documentation just kind of automatically. I've generated these proto files, they define all my interfaces, I throw them into a database, and now I can search that database and find out what my dependencies are. I can search that database and find out flow of information. I can decide that some information isn't flowing the right way. I can start to do some analysis through the interfaces, and it's automatically kept up to date. So George was talking about, you know, having what was it, 10,000 lines of documentation. Okay, so A, you don't want to write that, and B, if you have it, you don't want to have to read it, and C, if you have it, it's going to be out of date tomorrow. Okay, well, at least if you're using protocol buffers, you have some form of documentation that's always correct. It's guaranteed correct because your system works. So that's what I find interesting about protocol buffers. It's not so much the problem they solve as the side effects that they have. Okay, we probably talked too fast. So you need to know 5 different things if you want to be an architect. You need to know architectural principles. That's fairly easy. You need to know architectural processes. You need to know the environment you're working in. And each one of these topics has a lot more information. If I didn't talk so fast, I would have gone through it. I didn't realize I was going to talk so fast. So how do you get more information? Well, the weakness of software architecture in practice is that it doesn't say it says I shouldn't say nothing. It says very little about the environment in which the systems are run. So I wrote another book. That's what I do. And so the book on the right talks about the environment from the point of view of the cloud. So it deals with those topics I said are important. It deals with messaging, it deals with virtualization, it deals with containers, it deals with networks, and it also talks about things that don't show up much, like there's a chapter on disaster recovery. I mean, whoever teaches disaster recovery, you know, how do you learn about disaster recovery? Well, there's a disaster, you know, so you learn it on the fact, you know, and so it's got some topics like that as well. So since I talked so fast, I have a lot of time for questions. So ask me questions. There's one way in the back there.
Hi Len, thanks for the talk. I have a question. Say in your architecture, in the process of designing an architecture, when did you take into account limitations of tools and framework? And could be everything from, well, network or microservices limitation or UI. When do you take those into account? Because in your list, they come like last, but in theory, they could be a very important feature or factor that can influence your design.
Yeah, so I didn't mean to suggest that my list constituted a process. I meant to suggest that these are the areas that you have. And the answer is very unsatisfactory. The answer is it depends. Okay, and so you come in with a certain amount of knowledge. You exist in an environment. The system that you're modifying, assuming you're modifying the system, has made certain decisions about tools or frameworks. And so you go to tools and frameworks, sometimes the first thing. Other times you may defer it. So it kind of depends on where you are and the system that you're developing and how much you know about it. So we had a discussion yesterday, and David will probably talk about some of this, but you know, architecting is a process of evolution and making a hypothesis and testing that hypothesis and then changing the hypothesis. And so if you have a tool suite that you want to use, then you say, can I make this work? Within the style that I've chosen. If not, then I have to either change my tool suite or change the style. You know, so there's no good answer to that question. There's no definitive answer to that question. More questions? No, okay. Oh, troublemaker.
Len, can you talk about your thoughts about the differences between architectural styles and architectural patterns?
Oh, God, why?
I couldn't help myself.
Yeah, no, right. So I asked for that. So partially that's historical, and partially that's you're talking about different communities. So historically, David Garland and Mary Shaw came up with the notion of architectural styles. That was, what, 92? George, you know these things. It was a long time ago. And so architectural styles were around. And then the Gang of Four came up with design patterns. And then people realized that some design patterns were code specific and some design patterns were more architectural. But rather than say we wanted to call these architectural styles, they called them architecture patterns, just because it fits in with design patterns, and it's just different communities. So you can quibble about the differences, and you can come up with very specific kinds of things, and I think we have a sidebar in the documentation book that goes through this. To my mind, they're the same. How's that? It's kind of funny in terms of terminology. So these days you start to hear, or I hear at least styles a lot more. I don't hear architectural patterns so much anymore. So it just depends on who you talk to, I think. Other questions? Yeah. Well, get you a microphone so I can hear you.
Len, is there a list of anti-patterns that you would consider as you go through the architectural process?
So if you once you've chosen a style, there are things it's bad at, and the things it's bad at would end up being anti-patterns. So every style is designed for a certain purpose, has certain things it's good at and certain things it's not good at. So anti-pattern in style choice, I would say, are going to be the things it's bad at. You can also have anti-patterns in your processes. Okay, and now you're starting to talk about heavyweight versus lightweight, and how much design are we going to do up front versus how much are we going to let evolve, and all those kinds of questions. And a lot of that depends on the context of your organization. So if you're contracting with a supplier, you have to have a contract with the supplier that says what you're going to do or what they're supposed to do. That suggests that you have a design. If you are totally organic, then you can let the design, you make certain design choices and then you work on it for a while, and then you can let the design evolve a little better. So again, the pattern or anti-pattern is going to depend on the context in which you're working, in the organizational context. Once you choose a framework or a tool, so one of the rants that I do, when I started programming, I programmed in Fortran, and Fortran was very column specific, right? We had cards, you had to put certain things in cards, and as we moved to interactive systems, the columns were still maintained, and then they invented C. And with C, when you want to end a statement, you put a semicolon, you can use white space any way you want. It was wonderful, you designated comments in a certain way with a certain syntax. And now you got things like YAML and Python where white space is important again, I find that an anti-pattern. Why are we going back to making white space important? I don't know. People forget history. I'm not sure I answered your question, but Other questions?
Hi, thank you for the helpful and informative talk. If I had a group of engineers and I was wanted them to become better at DevOps, and I was looking for, say, a book that would come at DevOps from an architectural perspective, be very aware of that, perhaps that had interesting discussion questions in it, and was available at a large publisher, both electronically and in physical form. Do you have any books that you would suggest for that?
And it only costs 10 euros.
Where do I sign up?
Well, right over here. You can get it from Amazon, costs 10 euros. So George is prompting me to talk about the difference between publishing with a publisher and publishing with Amazon. What happens when you publish with a publisher is there's a certain overhead associated with it, and they have to make a profit somehow. So what they do is they take the cost of production and then they add their piece, and the book comes out costing $30 or something like that. If you publish on Amazon, then Amazon charges you delivery charges as an author. So I sell the book electronically for $10. They charge $1 or $2 for delivery. Or I sell the paperback book for $15. They charge $5 for delivery. You know, and so from an author's perspective, you end up getting the same royalties if you're publishing with a publisher or you're publishing through Amazon. From the reader's perspective, books at least could be much cheaper if you publish them themselves. But to answer your question, I would really seriously look at this book over here. Thank you for your question. Yeah. What you're going to hear here, I mean, we all got invited because we'd written books, and the sponsors looked at the list of books, you know, that people read and say, okay, well, we ought to get those authors. But then what you end up with is authors pitching their own books. So, you know, I don't know. Anyway, yeah, there was a question in the next row back.
So, thank you for the talk. My question is not maybe so funny as George's. I would like to ask you, I've done a little bit of research on my context, on my domain, and I found that none of the architectural styles and patterns suit me. So how can I talk myself out of that?
So partially what you're asking is, where can I find a good catalog of architectural patterns or architectural styles so that I can find one that's suitable. My feeling at this point in time is that I shouldn't say no one, it's very rare that you're writing a system that isn't similar to a system that already exists. And so I would look at a system that is similar to the one that you have in mind and see what they did. And then, you know, that might give you a basis. And then what you would do is, if you choose to more or less use the pattern, the style that they use, then you start to compensate for the particular qualities that are more important to you. But it's, you know, places like Google and Netflix and Amazon, you know, essentially invented scale. And so they had to create things. But most of us don't. You know, most of us are building a system that's similar to either ones we built before or that someone else has built. So I would look there. And that's, I mean, in a sense, you know, this is an old man talking. That's a shame. So, you know, greenfield development is usually a lot more fun than modifying an existing system. But what we've gotten to is mostly modifying existing systems. So Troublemaker is going to ask me another
Yeah.
question.
I'm not going to heckle you this time, Len. But I do have a question, though. That was kind of a serious one, but this one's even more serious. I'm fascinated that I'm looking up at the slide here, and I see a book on software architecture. And on the right-hand side, I see a book on DevOps for software engineers. And I'm wondering if you can talk a little bit more about the link between the two, or is there one? I mean, does architecture influence DevOps? Does DevOps influence architecture?
Okay, good question. So we had this discussion this morning, so I'm primed for this. So think about continuous delivery, DevOps process. You want to be able to deploy a service at any time. Okay, well, the service is dependent on other services. The service has clients. You have a new feature, and maybe that feature has been implemented in your service and not in the others, or vice versa. How do you arrange for that? And that's an architectural question. Okay, so you would architect in such a way that, well, at least what I advocate and what's in the book, is that you would architect in such a way that you put the feature inside of a feature toggle, and you distinguish between installing it and activating it. So the feature toggle becomes a runtime thing as opposed to a compile time thing, which was his original use. And you differentiate, you activate it once all your installation is done and all of the dependencies are there, for example. Or you would activate it, you would also keep it, you would enforce, the process would enforce things like backward compatibility. And there's a concept called forward compatibility, which means be gentle when something goes wrong, in essence. I heard a Google talk a couple years ago where they replaced a sensitive module in their file system. The module was originally written in 2003 or 4, and it had undergone 105 different versions of the interface. They maintained backward compatibility, and version 1 still worked if they had any clients out there using version 1. On the other hand, I talk to people at Google and they tell me, you know, this backward compatibility thing's really a pain. You know, it's hard. I have to do it, but it's hard. I don't like it. You know, so I mean, again, there's a tension. But those are all architectural things that are connected to continuous deployment. Take the example I used about logs. Okay, you're a first responder. You need the information in order to find the problem. What's the information? Where does it come from? Those are architectural questions. So there is a connection between architecture and DevOps. And you know, one of the things you do in general, and that DevOps emphasizes it, is how do you deal with errors? So you have two things you can do with errors. You can either prevent them or correct them. Correcting them takes time. Preventing them can be done through some combination of coordination, which means meetings, which takes time, or architecture and tooling and process. You know, the processes you use. So yes, there is a connection between DevOps and software architecture, and to go back to George's question, you can find it there. If anybody wants to ask about what it was like to be a programmer in the 60s, I have stories.
So yeah, hello and thank you for the talk. I want to ask you if, like, my mental picture of architectural styles and pattern is wrong. So I generally, the talk about design pattern as architectural pattern, and I like my mental picture of an architectural styles is something like REST or microservices. So I use pattern to implement architectural style. Is that wrong?
So repeat the question. I didn't quite catch it.
So I generally refer to architectural styles to something like REST or microservices. And architectural pattern in my mind are design pattern. So I use design pattern to implement architectural style.
So you're following up on Mark's question.
Yes.
The thing about the terminology you use and so on is really dependent on the people you're talking to. Who are you trying there are two options. One is you're talking to somebody that already has an opinion on that, in which case you try and use the language that they'll understand. The other is you're trying to convince them of a particular jargon that they should use. You're trying to teach them the jargon. It goes back to what George was talking about teams having the same underlying theory. And in that case, you need to make sure that the jargon that you're using is widely accepted. At one point, one of the critiques of software architecture in practice was that it uses terminology that no one uses. And I would interpret that not so much a criticism of the book as a criticism of the field. There is no standard terminology for some of these things. And so you could look at what we were trying to do as to instill a standard terminology. I wouldn't say we were horribly successful, but that was the goal, at least in retrospect. I run out of time.